going to talk about how to calculate descriptives. So measures of central tendency, such as mean, median, and mode. And the measures of variance, interquartile range, the range, standard deviation, and variance. With a special topic on biased standard deviation that is often used in many intro to statistics books. So I have a bunch of data that is continuous in nature, so you don't really want to calculate an average on a nominal variable, but we could calculate the mode on the nominal variable. So let's do a little bit of each, and let's talk about what do I do with nominal variables first. So let's go to Analyze, Descriptives, and then I like the frequencies window because it gives me more options, but you can also do this under Descriptives. So I'm going to pick frequencies. Now let's do party affiliation and location. Now both of these are categorical variables or nominal, where they have two categories each. And so really, I kind of limited in what I can discover from these, because I don't want to do an average on this, because an average would be like 1.2, and that doesn't really mean anything. So we'll click on Statistics. So if you have a nominal variable, you could look at the median if it were a little more continuous, like more of like a rank kind of thing, but median doesn't make a whole lot of sense. It's mostly going to be mode. Okay. If you weren't sure about the min and the max because maybe you entered the data and you couldn't remember if you did 1 and 2 or 0 and 1, we could use min and max to find that out. But generally, the most common thing you're going to get for the any kind of nominal variables is going to be the mode. So let's hit continue and OK. Alright, so it gave me, for party affiliation, it says I have 457 and I'm missing 1. The mode, or the most often number, is 0, and I've clearly labeled them 0 and 1. Okay. And so whoever the 0 group is going to be the most common option. That's probably a little easier to see in the frequency table that I got down here, and I can clearly see that Republicans have a higher percent than Democrats. For my location variable, it gives me a little 1 here, but it has that A next to it. Anytime you see this little A, it's down here, multiple modes exist. So it's telling me that there's more than one mode. I've coded this one as 1 and 2. So really the coding system, when you're talking about value labels, doesn't matter, so I've coded them differently, but it gives me the same basic output. Okay. If I look down here, it's clear to me that there is no mode, essentially, in this data set because they're the same, or there's 2 modes. So anytime you have data that's equally split, you can kind of say either they're no modes or they're all the mode, because that's kind of how it works. And so that's for categorical variables, or nominal, same words. If I have continuous variables, what do? So let's look at the data again. So I have a bunch of continuous variables, so let's calculate the averages for several of these. So I'm going to go at Analyze, Descriptives, and then Frequencies. Okay, I'm going to hit Reset to clear this out. Let's pick just a couple of them. Let's see. How about past, present, and future tense? We'll move all 3 of those over. I'm going to turn off display frequency tables because otherwise I'm going to get these giant tables where each decimal point is going to have its own frequency. And then it's warning me, by the way, unless you pick something else, nothing's going to happen. Thanks, SPSS. I got it. So let's click on Statistics. Now, anytime you have a continuous variable, there are lots of options that you can do. Okay, so let's do mean, median, and mode under a central tendency here. For dispersion, that's the same thing as variance. So I can get the standard deviation, the variance, and the range. The problem I have with range is that it subtracts for me. Pardon me. And if I was more interested in what's my min and max, I would pick those two. Okay, so range is going to subtract max from min and just give you a number of like how far apart the top and the bottom are. If you actually want to know what the top and the bottom are, be sure you pick min and max. The other thing you can get is the interquartile range or the quartile points by clicking quartile here. So continue and OK. Alright, so I didn't get frequency tables because I said no thanks. It gave me the mean for each one. So clearly present tense is used more often than past tense or future tense. It gave me the median for each one. Now remember that median is if you line up all of the data from lowest to highest, it's the middle point. And so these are all pretty close. When your mean and your median are fairly close together, that implies that it's a little bit more of a normal distribution. And then it gave me the mode. And for each of these, except future tense, it said multiple modes exist. So if I wanted to figure out what other modes there were, I would need a frequency chart or a histogram to figure out which of these were the highest. So let's get those histograms just real quick. So analyze, descriptives, and then frequencies. Click on charts. Let's ask for histograms and show normal curve. Continue, and OK. It's going to repeat this box because I asked for it again. Now under past tense, it told me the mode was 1.02. And so I could, one of the problems is when you have big data like this, it sort of squishes all these bars together. But I could sort of figure out what this bar is to talk about which ones are the multiple modes part. But for present tense, it's a little more obvious, 5.43. Okay. So there's actually several of these bars that are the tallest. And then for future tense, it is one of these up here. Okay. So this is the mode for a continuous set of data or scale data, interval and ratio is not always the most useful because you can get multiple modes and it doesn't necessarily mean too much in the sense of the fact that there might just be lots of decimal points really close together that all have the same height. And so if you're going to work with data that's interval in nature, the mean is better. If you're working with data that is very skewed, so you can see that our past tense variable is more skewed than our maybe present tense variable here, then the median's better. Okay, so modes are really for nominal data. Median is better for ratio data interval or ratio data that's skewed, highly skewed, like income. Mean is better for data that's sort of normal and is at least scale, so interval or ratio. The next thing it gives me is standard deviation. So this calculates the average distance from the mean from each variable. So it's about 1 point down from past tense. So if my mean, what was it? 1.76, so about here-ish. Most of the data is 1 point down, so 0.76, and 1 point up, 2.76. Okay, so remember standard deviation is the average distance from the mean, and it tells you where most of the data falls, is between these 2 points. Okay. The variance is the standard deviation squared, right? So these are the squared distances from the means. So most people don't tend to use variance because it is not in the scale, same scale of the data that you are using. So standard deviation brings it back down to the same scale. Okay. I can get the range here, so it tells me highest point to lowest point subtracted, which is why I really like having the min and the max as well, because I can see the points it's subtracting. So okay, it's 6.43 points, but that could have been 1 to 7 as opposed to 0 to 6. Okay. And the last thing it gives you is an interquartile range, but it doesn't subtract this one for you. It tells you the points at each of the quartiles. So it breaks the data into 4 different quadrants and tells you what point it is. So clearly at the 0th percentile it's going to be the minimum, and at the 100th percentile it's going to be the maximum. So it gives you 25, 50, and 75, those points in the middle. If you actually are trying to calculate interquartile range, you're supposed to subtract 75 minus 25. So in this first example, it would be 1.16, okay, if I do 2 decimals. And so the good thing is I got all of that very quickly. Normally this would take you a long time to calculate by hand, but you can get all those numbers pretty fast with SPSS. The only difference is this idea between biased and unbiased calculations. And so if you are doing sort of traditional research, we talk about the standard deviation as an unbiased estimator. And to make it as an unbiased estimator, we take sigma, which is that fancy E symbol. Where is sigma? There he is. So sigma, so the sum of all of the distances from the mean, so x minus the mean. But then we're going to square that. And if we don't square it, the sum of the distances from the mean always add up to 0. So we're squaring it so we can get a useful number. And then we're dividing it by n minus 1. And so that makes it the unbiased estimator. So the top is considered sum of squares, okay, because we're summing the squared distance from the mean. And the bottom is considered the degrees of freedom. So degrees of freedom is the number of values that can vary and keep the same score. So we have n minus 1, which is the most common estimator for degrees of freedom. And it's considered the unbiased version of standard deviation because it includes this estimate for degrees of freedom. And so we're not assuming that we know everyone in the population. We're assuming that at least one of these scores is sort of either unknown or we've had to estimate it, or the way I think about it is maybe I've screwed up something. And so that is a little bit larger of an estimator. And so when we make the number a touch larger, we're going to use standard deviation on the denominator for each of our statistical tests. And by making it a little bit larger, we're sort of making it harder for us to reject the null or find statistical significance, which makes it unbiased. So we're not making it easier on ourselves. We're actually making it a little harder, which in statistics makes it an unbiased estimator. And so that just sort of gives you a little bit room for error. So you're looking to make sure that you didn't mess it up by estimating in your favor. However, most intro statistics books, in the social sciences at least, talk about the biased estimator first. So the estimator for the population, whereas unbiased estimators are usually on samples. And so, make this all the same font here. When you're talking about biased estimators, we're going to use the same formula minus the fact that there's this 1 out here. So it's sum of squares divided by n. And I think the reason they do that is because they spend so much time talking about the average. So if you were to ignore this piece here, ex over n is an average. And so if we're talking about the average distance from the mean, it doesn't always make sense to go, well, it's the formula for averages, but we're going to toss in this extra -1 thing. And so they sort of start by saying, look, it's the average distance because it's over n, and averages are over n. But the problem with this biased estimator is it tends to be too small, which biases your test in your favor. Okay, so we spend a lot of time in statistics talking about how do I make sure that I'm not cheating, which is a type 1 error. So I'm finding things that we shouldn't be finding, or saying things happened when they didn't. And so if you're doing a real research study, you're going to do this top portion. Because you want to use the unbiased version. If you're in Intro to Statistics, it starts with this biased option. And there's not a spot in SPSS to really get the biased estimator. You can't just like turn it off and say stop doing it. And so we're going to cheat and make it do this for us so we don't have to do it by hand because that's lame. So here's how I found one of the easiest ways to make it happen. So the first thing you got to do is calculate the average for the variable you're interested in. So we're going to go Analyze, Descriptives, and then Frequencies. I'm going to reset everything. And let's pick a fun variable here, religion. So how much do politicians talk about religion? Okay. I'm going to turn off frequency tables because otherwise I'm going to get this huge table. Under Statistics, let's calculate the average score. And then for comparison here in a minute, standard deviation. So for this variable, I have an average score of 0.18. So first, get the mean. Okay. So my mean was 0.18. Second, we're going to calculate the deviations. But for comparison, I'm going to write down right here my unbiased standard deviation. So what did I get from SPSS here? I got 0.35. Okay, well, let's do 3 decimals. This is going to be very tiny, 0.347. Alright, so I have the means. Now to calculate the deviations, I'm going to use the transform window. Okay, so go transform, compute variable, and I'm going to call it deviations so I can remember what it is. Pick that same variable you're interested in, so religion here. You can double click or drag and drop. Okay. And then do minus the mean. Now there's no column for the mean, just type the number in, 0.18. Now, there's no good way to do squared. So I'm going to take this whole thing and copy it, so Control-C, and multiply it by itself. So what you end up with is x minus the mean times x minus the mean, which is the same thing as doing it squared. Okay. So I'm sure in this function group somewhere there's a nice pretty version of exponents, but this way is at least pretty simple to do, and it's sort of obvious what's going on. So it's x minus the mean times x minus the mean, so it's x minus the mean squared. Okay, remember that x is going to change for each person. So by putting in the variable name, it's letting me do, it's going to do all of the people at once. So you don't put in each participant's score, you tell it, use this variable and do one person at a time and do this to them. Okay, so this is going to give us the deviations from the mean squared. So hit OK. If you're looking at the output, it just gives you this cute little line right here. So I'm going to hit the star button, go back to data, go all the way to the end. So now I have the deviations for my religion variable. So this is how much each variable is different from the mean. And that looks sort of odd until you realize that this variable has more decimals than you would think out there. Okay. Alright, and remember that they're squared. So after we've calculated this deviations column, which is essentially doing this component, the next thing I have to do, there we go, is get an average of the deviations. So I've done the x minus the mean part. Now I need to do the e over n part. So that's going to create an average of that deviation column I just made. And so what I've done is I've just broken this into 2 parts because I can't do all of it at once. Okay, so I'm going to get a sum of the deviations and divide by n. Now the way to cheat and do that in SPSS is to just create an average of the deviations column. So let's go analyze, descriptives, and then frequencies. I'm going to take out my religion variable so I don't get confused, put in my deviations variable, and under statistics only pick the mean. And that will help you not pick the wrong thing. Okay, you could leave in all 12 options or all the different options we talked about earlier, but I think it's easier if you just pick mean so you don't look at the variance or the standard deviation column. Otherwise, you're going to use the wrong number. So hit continue and OK. So the mean is 0.12. Okay, so we got our new variance equals 0.12. And so what we've done is we forced it to do the math for us. And so this is not actually the mean, it's just a way to cheat to get to the mean or to get to variance. Okay, why is it variance? Well, remember, standard deviation is actually this formula, and you take the square root, or this one, and you take the square root. And so we've got the average deviations distance from the mean, and so that's going to be variance. If we want to then get the biased estimator of standard deviation, I'm going to take the square root of my variance. I'm going to do 0.12 square root 0.346. And so what you should find whenever you do this is that the biased estimator is going to be smaller than the unbiased estimator, right? So we make the unbiased estimator larger so we're not cheating when we get to the statistical test part, and the biased estimator is too small. Okay, so we're going from 0.346 to 0.347, and I said it would be kind of small. The larger your n, so the bigger the number of participants that you have, so in this particular study I have 458 participants, that's a lot, the larger the difference. Okay. I'm sorry, the more n you have, the less different they are. So the bigger sample size, the smaller the distance between biased and unbiased. If I had only had 12 people, you would have seen a big difference between biased and unbiased. And that's only really useful when you're trying to calculate it for, let's say, homework. We really don't ever use the unbiased estimator, the biased estimator, this stuff, too often because it is biased for a reason. And so we tend to use the unbiased one. But I know that lots of intro to stats books talk about the biased one and ask you to calculate it, so I wanted to give you a way to do that.